What's going on, guys? Welcome back to the channel. So since that last video I put up of measuring everything out on this motor, I've had quite a few questions and comments about how to use the tools, more in depth, exactly how to use and how to read those tools. So I'm gonna go over that today. Another update on the block, got it right here. So I actually brought that back to the machine shop and he agreed that he overbored it. So he was actually looking for another block for me. So we are waiting to hear back from him on that. So as far as the tools go, this is what I'm using. We got a bore gauge. We got a few different outside micrometers. You're gonna need a couple different sizes. This is a 3 to 4 inch. That's a 2 to 3. That's a 1 to 2. So if you gotta measure your, say your crank journals and your pistons, you're gonna need different sizes. So we got those. We got some of these little T-handle bore gauges. So that's really the basics on what you need. Obviously, some of this stuff isn't really high-end, expensive, top dollar stuff, but it will get you close and get a fairly accurate reading. So definitely close enough. So what I'm going to be doing is we'll start with the rods. Let's get these rods measured out. So what you want to do is you get your bearings in the rods, then you want to torque your caps. These ones are 22 foot-pounds, I believe. So we'll measure the big end of the rod, then we'll measure the crank journal, and then subtract the rod from the journal, and that'll give you your oil clearance. All right, guys, so I got the rod cap torqued down. So we're gonna measure the crank journal with the outside micrometer, and then we're going to actually set up the bore gauge for this rod end. And to set this up, this one actually has two different heads. This head is for 2 to 6 inches, and the smaller head is for a 1.4 to 2 inch. So you'll put the smaller head on because this is under 2 inches. And then there's all these different sizes of the little tips on it. And then there's also shims here. I got one here too, for varying sizes. So basically what you want to set this at is within the range of your rod, your journal measurement. So you're going to measure your journal with a micrometer, and then you'll set this to be within that range, so it'll compress a little bit, maybe shoot for halfway or something, and then you'll throw the micrometer in between this. You'll get it to compress, and then you'll zero the gauge out. You just twist that gauge, get that needle to read at 0, and then once you put it in the rod, it will, obviously the rod is bigger, so you'll get a measurement of, say, 2. That 2 is 2,000, so that would be your oil clearance. So that's the easiest way I found to do it. So let's set this up. I'll get my GoPro on and I'll show you exactly what it looks like. Get your outside micrometer and I'll show you exactly how to read this. I know this looks confusing to a lot of you, but it's really not that complicated. So this is a 1 to 2 because my journal is under 2 inches. So you'll get it, put it over the top, obviously, and then slowly tighten the end. And what you want is, if you've ever used a feeler gauge, you know what I'm talking about, to where you get the resistance of actually touching the journal, but loose enough to where you can still slide it, but you have some resistance. So then you pull it off, you'll lock it so you can't turn it anymore. So that's your measurement of the crank journal. So how to read this? This is a 1 to 2, like I said. So this would be the maximum this goes is 2 inches. So you'd start with 1 inch because it is below 2. And then these numbers here, the 0 through 9, that would be 1 point. So we are after the 8, before the 9, so it'd be 1.8. Then you go to the lower dial here. So there is 4 marks between the 7 and the 8. So that means every one of those marks is 25,000. So we would be at 1.8. We are just over the 3rd mark, so that would be 75 thousandths, so 1.875. Then this dial here is, you'll basically add that to the end. So 1.875, we're past the 5 but before the 6, so that'd be 1.88. And then to get our last number, which would be the 10th of a thousandth, is this range here. So these numbers on the bottom ranges from 0 to 9. So if you look at it, it's almost to the 6, so you know it's going to be at the higher end. So what you want to do is find the lines here that line up the best. So looking at it, it looks like 8 lines up the best right there. So that would be 1.875 plus 5 is 880, plus the 8 on the end would be 1.888 or 1.8808. So then make sure that's still locked. It's a little bit of a trick to get, you want the highest reading. So it's a little bit of a trick. You got to mess around with it to get this to the highest reading. So looks like we're close there, about a 10th out. So you can just adjust this dial and keep doing it until you're confident that it's 100% zeroed out. I just slipped off there. It's a lot easier if you put this in a vise, but I'm gonna do it freehand right now. So oh, right there. So you can see if I can make it back up there. Right there is zeroed out. So that's the largest measurement you can get from this micrometer. So when we stick this in the rod, we will get our clearance. So then all you got to do is kind of angle it like this. Put this end in first because this is the side that collapses. So you put this in, get it in the rod, and then you'll just move it to where you get your biggest measurement. So looks like we're just under 2 here. So about one thou and about 9/10 of a thousandth, pretty close to 2 thou, which is in spec. So we are good to go here. So that is a good way, a very accurate way to measure your oil clearance. All right guys, another way you can do this is with a T-handle. If you do not have a bore gauge, these aren't quite as accurate. If you do them every day and you know exactly how to do it, probably a little more consistent. So the way you do these is this top little handle here locks it. So when you compress it and tighten it down, it locks. So you want to make sure that's loose. So you stick it in your bore. You'll kind of move it up and down a little bit just to try to get it centered in that bore. And then you'll tilt it forward just like that. You'll lock that top and then you'll just pull it out like that. And then you'll take your micrometers and adjust them, or you'll just basically get this measurement here. And these are rounded just like that bore gauge is. So you kind of have to mess around with it a little bit, kind of pivot it, move it around until you get the resistance you felt when you measured your crank, your journal. So enough to where you feel it, but you can still slide, smoothly slide it. It's not binding up and super tight. And then you'll just get your measurement. So we are at 1.875. We are above the 7. So that would be 1.882. And then the line that lines up here looks like 5 right there. Yeah, so we got 1.8825. So that is the measurement of the big end of the rod. So then you just get your calculator out. 1.8825 minus the crank journal, which was 1.8808, I believe. So 1.7 thousandths clearance. We got 1.9 with the bore gauge. So we have 2/10 difference. That could be just different tools. It could be different feeling with this, you know, it wasn't completely centered, something. But either way, within 2/10 of a thousandth, that's pretty accurate. Pretty happy with that. So either way, I think either way is definitely accurate enough. I mean, obviously, the spec for this oil clearance is 4/10 of a thousandth to 2.4 thousandths. So, or 2 thousandths and 4/10. So we are well within spec, and like I said, either one of these tools will do the job. All right, guys, the next thing I'll show you how to measure is main bearings to the main journal on the crank. So just like everything else, get your bearings in. This crank is over 2 inches, so we're going to be using the 2 to 3 micrometer. So open her up. Make sure you clean your journal off. And make sure you're missing the oil hole. There's these oil holes in it, so make sure you're not stuck in one of those. All right, so this one, since it's 2 to 3, we start at 2 inches. So 2 inches, we're past the 1. And if you can see that, we are right before the 2.5. So we're 2.4. So 2.1, 2.4, 0. And we are, let's see, 8. So 2.1408, or sorry, 2.1248. And then this is obviously too small, so we're gonna have to get a different tip for it. And I actually have a spreadsheet of everything, what the measurement is for everything, but I don't know where that went. So we are doing the old shot in the dark. So what we got to do is, obviously this one is too short, so let's jump up a couple of them, see if that gets us close. Nope. All right, that one should work right there. So if you can see, when this is fully extended, it's got to compress. So make sure your mic is locked down. We'll do the same thing with zeroing it out. All right, we're gonna call that good right there. Right at 0. Then you gotta be careful, especially on these bearings. The bottom one has a oil channel, so just make sure you aren't stuck in that channel. So yeah, these are my previous measurements here. 2 and 4/10, and that's right about what I'm getting here. If you can see that on the camera, right on the dot at 2 and 4/10. All right, so once again, this is 3 inches, over 3 inches, so we're gonna be using a 3 to 4 mic. So on these particular pistons, you got to measure 10 millimeters up from the bottom of the skirt and at 90 degrees from that piston pin. So same deal. And also another thing with these mics, so you can turn it with this, And then also this little knob at the end here, and that basically, it clicks when it feels resistance. So if you're not used to measuring with the feel of the resistance, you can also use this. So once it bottoms out and gets just a little bit, you can see right there, it's clicking and it's got just the right amount of resistance. So you can also use that too. So we'll lock this down. So this piston measures 3 inches. We are just under the 50 mark, so 50 thousandths. So we are 3.1. So basically you go, it's easier to write some of these down. We go 3.125, and then you add the 20, 21, 22, 23, 23, we are 8, 4, 1, 3.148, and then you'll go with this last number here, which lines up with a 4. So that is a touch under what it should be. That's why I don't like using this. I've always done it by feel. I feel it's more accurate, so we'll do it how I usually do it. Right there. So we are 3.125, 20, 21, 22, 23, 8, 4, 3, and an 8. So that, 3.1488 is exactly what that piston should measure. And I verified that. These pistons are marked. It's in millimeters. 79.960 millimeters is 3.1480. But this coating is 8/10 of a thousandths thick. So that's where I get the extra 8/10 right there. So that is our exact piston measurement. All right, guys, I actually found the spread out of measurements here to set up your bore gauge. So this already has the smaller head on it. So I'm gonna swap this back out. So to get your correct setup, you basically go off this chart here. So you'll take your piston diameter, 3.148. So if we go 3, which is the number 6, this is what I have, that'll get us to 3 inches. And then I had a 1.2 and a 0.4 spacer in here as well. So you stack these up underneath here, and that'll raise it out that much more. So you'll just basically want to take your piston measurement and go just slightly above. So 3, and then I have a 1.2, so that'll be 3.12, and then I have a 0.04, so that would be 3.16, and my measurement is 3.148. So that gets us just slightly above our measurement for that piston, so we can compress the gauge and get a reading off it. So then you'll just thread that in, and then just like we did on the last one, so we are right there, right at 0. So like I said, when I put that in the block, we'll get our oil or our piston to cylinder clearance. So when you're measuring a cylinder, you want to measure the top, the middle, and the bottom at 3 different locations to make sure it's not out of round and not tapered. So you just stick this in. So we got 2 thousandths there. 1.3, 1 2/10 right there. Or 3/10, sorry. And here we got 2 3/10. So you can see this top is out of round. Then we'll hit the middle. We are at 3 1/10 there. 3 4/10 there. And 2 5/10 there. Then we'll go all the way to the bottom. We got 2 9/10, 3 6/10, 3 6/10. So you can see the cylinder is not round and it's not square. It's kind of tapered. It all four kind of tapered up at the top. So one other thing I haven't done yet, and for a very good reason, is I haven't checked the ring end gap. That's because I don't want to start grinding my rings to fit a bore that I'm not going to use. But for this video's sake, I'll show you how to check ring end gap. All right, so the best way to do this is take your top, this is my top ring, and you get a piston. So you'll stick it in the block, kind of at an angle like that. Then you can just pivot it around, and then take your piston, drop it in, and push that ring down to square it up. Make sure it's square, flat, and straight, and then you can see your gap here. So you'll just get a feeler gauge. And what I'm gonna be running is a little bit looser of a ring end gap just so they don't butt. So I'm gonna do 0.4 millimeters top ring, 0.48 second ring. So that actually is perfect. Curious to see what this second ring is. Holy smokes. That is a huge end gap. Why is that so big? Guys, I can't stress enough checking everything. So these are all brand new pistons, brand new rings, everything is brand new. I haven't touched these rings, and I got 3 of these second compression rings right at 0.48 mil, right where they should be. If you want to see right here, 0.48 millimeters. That one's good. This one here. Look how big this gap is. 0.48 is literally flopping around. Curious to see how big it is. I don't even know if I have a big enough feeler gauge. I probably don't. 6, 7, 75. 75 is loose. Let's try a 75 and a 48. Doesn't fit, but all right, this fits. We have 75, 0.75 millimeter, 0.25 millimeter. That is 1 millimeter, and it fits in the ring end gap. Just to show you guys, I'll grab another set. This is a second compression ring we're measuring here. So this is another one. See, that gap's a lot smaller. We'll get the 0.48 out. Fits nice and tight. So I have a bad ring, apparently. I am going to call the shop I bought these from and ask them what is going on. This is the bigger one here that I measured bigger. Just lining them up, you can see right there. You see how much bigger it is. Hopefully you can see it on the camera. So, like I said, I'm going to call the shop and tell them I need another ring, because that is not going to work. I went and verified all the top rings. Those are all good. I haven't done the oil ring yet. I'm going to check those too, but this is why we double check. If I didn't double check this stuff, I would have a ring that's way too big. I would have cylinder bores that are out of round and tapered. The motor would probably still run, but it wouldn't run as good as it should. So double check your machinist, double check your parts, double check everything, guys. All right, guys, there it is. So double check everything when you put a motor together, and in general, double check everything. Like I said, these parts are sometimes screwed up. If I had to take a guess, I would say that ring is for a stock size piston, because it is right at 0.5 millimeters bigger than it should be, or smaller. The ring and gap is too big, so the ring is technically smaller than it should be. So you can see right here, look how big that gap is. I'll take a 0.48 feeler gauge. You can see how loose that is. I was able to fit a full millimeter worth of feeler gauges through that ring end gap. So I'm calling the shop. We're gonna see if we can figure that one out, get a new ring sent. I checked every other ring and they're all good. So just this one weird ring. So I really hope this helps you guys out. I hope it raises a little bit of awareness for shops, for parts, for everything. Like I said, this motor, I mean, it'd probably still run, but not that great. The rings probably wouldn't seat with a bore that's not round. You have to have a round bore so the rings will seat. So it'd probably burn some oil, and it'd probably be a little clanky because of excessive cylinder to piston clearance. So with that being said, measure everything. And if you guys want to check these tools out, I'll have them all linked down below. Like I said, some of them are just cheaper. This is a Fowler brand bore gauge, but I think we verified in this video it's pretty accurate. I was getting the same exact, basically within 2/10 from the bore gauge to manually doing it with that T gauge. So I would say for the money, it should be accurate. I mean, if you're going to do this every day, if you're a machinist, obviously you're going to have top of the line, but for us guys in our shop, this stuff will work just fine. So I really hope you enjoyed it. Give it a thumbs up, give it a comment, let me know what you guys think of the video, and stay tuned on the channel. I actually just got a call from my machinist. He found another block, so he's gonna pick that block up. And I can't be thankful enough for, yeah, he screwed it up, it's his fault, but the majority of people in this world would say, screw you, dude, you're out of here. And, you know, not do anything for you. He's going out of his way. He's gonna buy me a block, he's gonna pay for it, and he's gonna machine it. Again, yeah, I know it makes sense that that's the right thing to do. Obviously, it's the right thing to do. He screwed it up, but not a lot of people will do that for you. So lucky on that one. I'm glad he's gonna make it right. And if this one turns out, you know, he'll get my future business. If he didn't do this, he definitely wouldn't get my business. And I may be building these things more often. So definitely stay tuned on the channel. We're gonna have a block, hopefully within, I would say, a week. The only crappy thing is I gotta wait for another torque plate. So hopefully that doesn't take too long. The last one, it took like a month to get here, but I talked to the guy and he said it shouldn't be too long before I could grab it and have it in my hand. So that is good news. So I don't have really a whole lot other things to do besides wait for this motor and get this thing together. So I guess we're just gonna be waiting for that other block, and then we'll get back at measuring more stuff, making sure it's all in spec, and hopefully we can get this thing together soon. So thanks for watching, guys. We'll see you in the next video.